Welcome, everybody. Thank you for joining us at the OTF Connects webinar with Lisa Floyd, and we will be exploring the power of variables via Coding for Math class. What a terrific title for us. I'm very excited to do this one for Lisa tonight. She and I were both at a technology conference a few weeks ago, and I've heard her name around for years. She's done some great things in this field, and I know she's looking forward to challenging you. I'm going to turn it over to her now, and she's going to continue to the introductions, and have a great session, everybody. All yours, Lisa.
Okay, thank you so much, Trish. And are you hearing me okay?
Yep, sounds good.
Okay, awesome. So I'm so glad that you can all join me today. I see a few familiar names in the room here, so thank you for coming on here. And I'll just quickly let you know about some of the things that I do. So right now I'm full-time with Fair Chance Learning, and we deliver professional learning and speaking usually about computational thinking and coding. And I've been supporting school districts around Canada, mostly in Ontario, but some in Newfoundland and in British Columbia. And I also am an instructor at Western University. I teach a course called Computational Thinking in Math and Science Education for pre-service teachers, and we do a whole bunch of coding activities, mostly geared towards math, but also science. And I've also, because I had just finished my master's in math education, I had the privilege to work as a research assistant with a couple of professors who were researching computational thinking, and so we've been able to work with them and also co-author a couple of papers on computational thinking. One of my favorite topics. I can talk all day about this. If anyone who knows me knows that I will. So I'm also currently on a leave of absence from Thames Valley District School Board. I taught computer science for 13 years and also taught math, science, and cooperative education as well. So I'm glad to see so many of you on here today. And as Trish said, we will be providing you with links throughout in the chat window, and also at the end I'll have a document that has all of the links that you'll see in the webinar today. So you don't have to worry about jotting them down. I'll give you one final document with every single link, so that, and it's annotated as well. It tells you what they are. If we haven't yet connected on Twitter, my Twitter handle is on here. It's Lisa Ann Floyd. Make sure you include that E. The person without the E is definitely not me. Now everyone's going to want to check. My email address is lisa@fairchancelearning.com. So if you have any questions afterwards, you can either DM me or send me an email, and I'm always happy to answer. I really enjoy troubleshooting people's programs. It's fun for me to debug. I do have a blog that I haven't written on recently, but there are some resources on there. So if you want to check it out, it's lisaannfloyd.com, and there's some ideas that might actually help you out as we get into the Hour of Code Week coming up next week. So we're going to get right into things. But I do want to know what grade you teach or what grade you support. I know sometimes we have some learning coordinators on here, and I'm just curious to know the group that we have today. So I thought we could maybe use our little, I forget what Trish called them, but the little pictures. So for example, I'll put a little happy face beside the word pulse, and maybe you can indicate on there, or you can type in the chat window A, B, C, D, or E, or the grades, as Alicia has there. Clip art. Thank you, Trish. Okay, so we've got kind of a mixture of everything, a lot of junior grades and some primary grades as well. Okay, and I knew Jamie was on here, so I knew we had at least one high school. Okay, awesome. So that gives me an idea of what to expect. I won't focus too much on high school. How do I add in a checkbox? So you can see medicine, there is like a vertical menu possibly, and you should be able to click on the happy face there. And otherwise you can just write in the chat window. Okay. So thank you for helping me out with that. Gives me an idea. So I'm going to go on to the next slide now. So I'm going to talk a lot about computational thinking throughout this webinar, and there's so many definitions of computational thinking and interpretations out there. So I will talk quickly about what I mean by computational thinking. I also just want to point out that we know that it's a skill that will help our students in all subject areas. So by developing their computational thinking skills, we will see a positive impact on all areas of students' learning. And we're also looking to help our students to be thinkers, computational thinkers, rather than storage bins for information. And hopefully by giving them the opportunity to do some coding, we're helping to develop their computational thinking skills. So these are the terms that you'll often see in papers or definitions for computational thinking. So we've got pattern recognition, algorithmic thinking, decomposition, taking a big problem, breaking it down into smaller, more manageable pieces, and I'm going to talk about abstraction a little bit as well today. Those are what we'll focus on for the majority of this webinar. Now we'll also, oops, I'm using my arrow keys rather than clicking. We'll also be doing some debugging. You'll find that every single program you make, you'll have lots and lots of errors, so there's always opportunities for debugging. There's also an opportunity today to do some remixing, so I'm going to give you some links to some programs, and then you can remix them and play around with the code and see what happens when you change variables. And then also iteration. So when you make a program, it is a computer science term, but it also is something that we use when we're creating programs. Students will make programs, and then they'll end up getting feedback from their peers, and they'll get feedback from their teachers and formative feedback, and then they're able to adjust the program and make it better, and they have multiple iterations of their program. I also talked about this a couple of weeks ago at a presentation. I think it's important as well that we give our students the opportunity to be creative with what they are making and what they're coding, give them a chance to be innovative in their thinking, and also to consider the human element. So make sure that we're thinking about who we're making our programs for. Of course, it takes a little bit of playing around with and actually doing some coding first to understand how you can start being more creative and how you can consider the user. But eventually you do want to get that way where you're giving your students the opportunity to use their imaginations when they're programming. There's a lot of potential there. So today we're going to be focusing on coding, and we can use coding as a context to develop our computational thinking skills. And I believe it's one of the best ways to develop computational thinking in our students, and so that's why it's awesome to be focusing on coding. And of course, also, our students are surrounded, and as well as us, surrounded by technology, and we want to make sure that they can become active, they can be engaged in technology and active authors. They can become authors as well, and it helps them to understand when they're using technology if they have a little bit of understanding about programming as well. So it's another reason to be doing coding. So not just to create a whole bunch of programmers, but to also create computational thinkers, and as well because the technology is important. And I'm going to be showing you some examples today, and then I'm going to, for each program that I share with you, I'm going to give you some extensions. So the great Michelangelo once said, the greatest danger for most of us lies not in setting our aim too high and falling short, but in setting our aim too low and achieving our mark. So coding affords us this opportunity for a low floor. There's multiple degrees of readiness available, but it also allows for us to challenge our students. There's always something more you can do, and then you can give them ideas all the time to get them to push them a little bit further as they create programs and they're participating in coding activities. So today I will be modeling that by giving you some programs to try, and then I'll share with you an extension that you may or may not be ready for depending on your experience with coding. But you'll certainly have those links to play around with after, and maybe you'll have some ideas to share with your own students. I thought we'd try out another poll here. Again, you can use the clip art, or you can indicate in the chat window. I just want to know your prior coding experience. So limited, some, considerable, or thorough. And this will help me today with whether I should focus more on some of the basics or maybe some of the extensions. And of course, coding is awesome because I can differentiate really easily with it, so we can adjust depending on your experience. Is that check mark way up there? I mean, you have no experience, or is it just wasn't sure if someone was making a joke. Okay. So far I see that most of us have limited or some, but a couple considerable and thorough. Awesome. Okay. That's very helpful. Thank you for sharing that with me. So let's get into what variables are then. So you'll find once you get comfortable using variables, you have so much more that you can do with your programs. They really do give you power, and they also give you the option to interact with the user. So variables can be in the form of numbers, or they can be in the form of words. And I think of variables like containers. They're going to hold information, and they're going to store this information for you. So it's going to take up memory. And just as the name suggests, the word vary is in there, so they will change throughout the program. And they could be in the form of numbers like integers, whole numbers, or real numbers with decimals. And in some programming languages, you actually have to indicate the type of variable you're going to use. It might be an integer, it might be a number that contains a decimal. It might also, a variable could be a string or a word. So for example, when a computer program asks you for your name, it will store it in a variable that will hold a string. But it could also hold the date or other symbols as well. So those are the different kinds of variables you might be working with. So the variables could be the score of a game. So anytime you have a game, a program like on the Xbox or PlayStation that has a score, then that is being held in the variable. It could also hold the answers that you're doing for a trivia game. Each answer will be stored in the variable. So we'll talk about the steps to incorporate variables in your program before we actually get into some examples of programs that you're going to be programming today. And the first step to do when you're going to use a variable is you need to declare a variable and give it a name. So you're basically saying, I'm going to use a variable and it's going to be called whatever. So in this example, I have number of steps is going to be my variable. Now you'll notice that the name of my variable is num steps. And then to try and get my cursor to show up for you, I might need to just help in getting my, oh, maybe I can just do this. There we go. I'll use that. So this is a variable name, num steps, and you'll notice that I don't have a space in it. Now, when you're doing, when you're programming in Scratch, you can actually have spaces in your variables, but pretty much every programming language that you'll use, if it's text-based, you'll have to not include a space. So that's why I tend to get in the habit of not including spaces when I name my variables. Now you can see, if you were to do this in Scratch, which we'll be doing in a second, and I will show you how, you go to Data and then click New, or click Make a Variable. So those of you who have not done anything in Scratch, don't worry, I'm going to show you this in a second. I just want to go through the steps before we actually try coding it, and then we'll review these at the end. And I see a question from Madison, are variables always strings and not numbers? So they can be strings or they can be numbers. And in some languages you have to actually specify whether it will hold a string or whether it will hold a number. So it just depends on what programming language you're going to be working with. So in this case I have declared a variable called numSteps in Scratch, and there's where I enter my variable name. Now if I were to work with a programming language such as Java, so Java and JavaScript, by the way, are two different programming languages. JavaScript is more for web-based applications, and then there's Java. So in Java, to declare a variable or say that you're going to use one, you indicate it by saying the type of variable, so int stands for integer, then indicating the name. And you'll see there's also like a semicolon here, and that's just called syntax. So that's the beauty of Scratch. You don't have to worry about those little semicolons or commas. That would be syntax, and then the students can just focus on the logic rather than getting lost in the syntax in the text-based programming language. But I thought it was a good idea to just show you how you would declare a variable in Java. So we're going to go to our next step now. So once you've declared a variable, you can then initialize it. So there's 3 steps to doing this. The second step, or to using variables, the second step is to initialize the variable, and that means give it a starting value. So if you recall, our variable is called numSteps. So in Scratch, you use the set block, and I'm setting it equal to 0 at the beginning. So let's say we're making a step counter. In this case, we're actually going to be counting Scratch's steps in a program in a moment. Every time Scratch moves, we're going to increase the number of steps variable by 1, but we need to start off with 0. So as soon as I type in num steps equals 0, if it was in Java, so this is how you would initialize it in Java, you just put an equal sign and give it and type in 0. In Scratch, we say the step block. And as soon as I do that and then press the space bar if it was Scratch or run my program in Java, the 0 will fill into the container. So when you declare a variable, you basically make this container, this square, and then when you initialize it, you're filling in the variable value. So it now has a value of 0. I'll go to my next slide. So here we're going to be using the variable or updating the variable. So once you've initialized it, given an initial value, you can then use the variable. And in this case, I'm going to, every time Scratch moves, I'm going to change my variable by 1. Now up here you can see in Java, this is the line of code that you would use if you want to increase your variable by 1. So recall that our initial value was 0. So 0 plus 1 is 1. So if I go to my next slide, then the value of num steps was 1 plus 1 gives me 2. And in Scratch, it's a little simpler. We just have to change by 1. So every time we click on the up arrow here, in Scratch, you'll see that our variable will change by 1. Let's click on the next one. So again, now it's 2 plus 1. It gives me 3. We've got our change by 1 in Scratch. And when I click on the up arrow, it'll increase by 1. And then 4. And that's it. So here we're going to start a program. You're going to add to a program that I've already started for you. So if you can go to this link, I think that she's already done it, put it in the chat window. So you can just click on the link that's in the chat window, because as Tish said at the beginning, this link on the slide isn't live. You have to use the link that's in the chat window on the left side there. So we're going to go ahead and declare, initialize, and use a variable in a program, in a steps program. So the link will take you to a program that I've started for you, and I'm going to show you how to make a few variables, and then, or make a variable, and then we're going to move our Scratch character around the screen. So what I'm going to do now is share my screen with you. So in a second, you'll see my screen come up. But what's nice is that you can still see the link on the left-hand side. Okay, so you should see something like this. Hopefully you see, I guess I said something like this, but what I see is a little cat, and then I also see left, up, right, and down arrows. So I'm going to declare a variable, and I'm going to click on data, so you can see data is in orange, and then I'm going to click on make a variable. So in Scratch, we have all of these drawers. One's called motion, look, sound, pen, and each block inside of each drawer has a certain color. So we're now on the data blocks, and everyone's going to be making a variable. Now, if you prefer to just watch, you're welcome to. I will give you the final program for this as well. So if you just want to watch me and not do it along with me, you're welcome to do that as well. What I find is it's useful to split my screen. So if you have a Windows computer, you can hit the Windows key on the bottom while you're selected in the window, and then hit the right arrow, and that will split your screen, part of your screen to the right, and then you can do the same for the left-hand side. Or you can just click and drag your window to the right, and then click and drag the other window to the left. So that's just an option for if you want to have two screens up. So I'm going to call my variable, as you recall, num steps. And again, I didn't include a space because in other programming languages, the space will not work. Then click on OK. There we go. And so now I have a variable called num steps. So what I'd like to do is, remember, once you've declared a variable, you then want to initialize it. So when I hit the space bar, I want it to change or set my variable to 0. So you'll see under data, you've got the set block. You're going to grab the set block and drag it underneath the space bar key, as you can see that I've done here. So now when I hit the space bar, it will reset my variable value to 0. What I'd also like to do is make it so every time I hit any of the arrows, so if you move your arrow around right now, so hit your left, right, and down arrows, you'll see that your scratch character, your little cat, will move around the screen. And right now, your number of steps variable that you should see on your screen has not changed. And you can see my mouse is underneath it right now. And that's because we haven't added that change block. So you can go under Data now and grab your change number of steps by 1 and drag it to each of your arrow keys. So no matter what arrow you will click, it will start to accumulate or increase your number of steps. So I'm going to be clicking my arrow key, and you can see now that my number of steps is a little bit delayed there. There we go. You can see my number of steps is increasing every single time I click an arrow key. Now if you wanted to move your character faster, you can just change, it says move steps. You can change that to 10, but then if you move, so for example in my up arrow, if I want to go faster up, then I would change that to 10. But then I'd also change the number of steps in my change block to 10 as well to reflect that I'm moving up by 10 and I'm skipping by 10 as well. So it's just a little tip if you'd like to do it. So that's that program. I'm going to return, if you have any questions, I can still see the chat window. So I'm going to return now back to the slides. Okay. So you can see that that program had a character that moved around as the arrows were pressed, and then we kept track of the number of steps the character moved each time it moved around. So if you look, here's the solution. So this is, if you weren't able to complete that program, this is the actual solution. So this is optional for you to click on. It has the answers. And I see a question from Morgan. It says, where did you say the number of steps was changing every time you clicked? So you should be able to see on the top left-hand side if you were able to make a variable under data, as you'll see in the sample program that just put in the window. You should see on the top left-hand side a variable block that says num steps. That's where you should see it. Okay, so I'd like to add a little extension. Now this is quite a big extension. It says here, determine the perimeter of objects in a photo. Use proportional reasoning to determine the actual length of the objects in the photo. So I'm going to show you now an example of a program that's a little bit advanced, but I'd like to show it to you anyway. So you have access to this link, so here's the next link. And I will also share my screen in a moment. Okay, so I've done quite a bit of extra on this program here. So this would be something you could share with your students, or you could strive to get to eventually. But what I've done is I took a picture of something in my kitchen. So this is the desk portion of my kitchen. And then I took measuring tape and I actually measured the distance that you can see. It says 80 centimeters. From the bottom of that cupboard door to the top is 80 centimeters. Then what I did is I made it so that, so if I click on the green flag, it moves my cat to the bottom of the drawer. So then, when I click on my up arrow, you can see that the number of steps is recorded, but also the number of centimeters. Now watch when I get to the top of the 80 centimeters, and you can try this if you want. Click on your green flag first. When I get to num steps 136, so I just walked 136, I got to the top of the 80 centimeter mark. So what I did is I actually created another variable. So this is quite advanced. I just want to show you that once you get more comfortable with the program, you can use proportional reasoning. So I took my 80. If you look on the code, I'm just going to make mine a little bit bigger, because this is the part I'm focusing on now. There's an operator, and I'll show you how to do operators later. But there's a division operator there. I took the 80 centimeters and I divided it by 136 because when I moved the cat up in the Scratch world, it went up 136. So now, every time I move my arrow, it takes into account, on the code there, you should see it in a second, there you go. It takes into account that it's moving that amount by centimeters. So now when I move my cat around anywhere, I'm actually seeing the real value in centimeters of my cupboards. And what you could do is move the cat around to any spot on your screen, press the space bar, that will reset it, and then I can figure out the perimeter of different objects. Now you can do this with maps. Of course, with maps, and you've got a couple different calculations to do for the proportional reasoning part. But there's all kinds of ideas that you can do here. So you can do this with students can take pictures of anything in their classroom, throw it in, and they can use this program that I have created here for you. You would just have to measure different objects and then indicate in that operator that whatever the amount is. So if you find a standard amount to measure, mine was 80 for this, and then I divided by the number of steps when Scratch moves. So it's just something, an extension, just to let you see the possibilities. So I'm going to go now back to my slides. Okay, so again, you could have clicked anywhere now on the screen and then just hit the space bar, and then you can move your character around and it will figure out the number of centimeters in your picture. So proportional reasoning there for you. Now let's say if you want to do something simple like scorekeeping, you can go to this program if you'd like to. And then what you can do is, I'll let you just go to that link. I won't bother sharing my screen. You might have to click the green flag though. So I'll just say it again, you might have to click the green flag. But then when you click on each of the pictures, you'll see that the scores will go up by 1. So let's say you're playing a game with your students. You can change these images. But let's say we had one team called the Senators and one called the Leafs. Then you can play your trivia game and they can just click on the actual images on your projector or on your screen, and they're using Scratch to keep score of a game. And thank you, Jamie, for indicating that if you want to save their programs, you'll need an account. So you can actually click on Remix in any of the programs that I've given you today, but I'll also give you all the links to the programs later as well. So there's score. You can see how simple it was. I have a space bar that resets my scores to 0, and then I also have a when this sprite is clicked for the Toronto Maple Leafs, and on this side I have when the Ottawa Senators is clicked to increase it by 1 on the other image. So that's all the code I needed for that program. So we're going to move into some math now, and I was just curious if anyone's coded with students in their math class. Maybe you can use the clip art and indicate, or indicate in the window. And while you're doing that, I'll answer Shannon's question. How did you get the Leafs and Senator images? What I did is I just went to Google Images, searched, and found those images. And then when you're in Scratch, there's a new, right beside New Sprite, there's a little folder. And you can click on the folder and look for the file that you saved. So you can save any image you want and import it into Scratch as a new sprite. No problem, Shannon. So I can see we're about 50-50, I think, for who has and who hasn't. Awesome, and I can see the student live in some cases. Great. And I think we're going to see a lot more after next week, giving it a try. And Scott says a little, but I know that he's done a lot. Husband's math lessons. Awesome. Are you talking about my husband, Shannon? My husband's math lessons? Oh, okay. I didn't realize that was the name of the conference he was at. I thought he just went to a Raptors game. Awesome. I'm glad that Scott was able to help you out, Cinda. Okay, so I'm going to go to my next slide. Again, it looks like 50-50, so that's cool. So we're going to do a simple program where we add 2 numbers together, and then we can take it to more places after this. So I'm going to show you how to do this, slowly but surely. And if you'd like, you can just watch, and then I'll share this link with you after. So we're going to share my screen, and what you'll need to do then is start a new Scratch program. So if you have a link to Scratch somewhere, just click on File and New to start a new program. So I'm going to go New. And you can just discard contents, don't worry, because I'll give you the links to these programs later. Okay, so here it goes. We're going to make a program that adds two numbers together, and just put your questions in the window, and hopefully I will see them. So we're going to go to Events when the green flag is clicked. So under Events, the brown-orange color, grab the when the green flag is clicked. I'm also going to make a few variables. So because we're going to add two numbers together and then spit out an answer, we need three variables. So under Data, make a variable. So Data, make a variable. I'm going to call the first variable num1, and then click on OK. So Data, make a variable. The variable name is num1. Click on OK. I'm going to do another one, num2, and then click on OK. And the third one, you can call sum or answer. So I'm going to call it answer in this case. And then click on OK. But of course, it's a good opportunity for you to discuss variable or discuss names of certain numbers in a number sentence. So you could say sum here. And then when you do division, you could say divisor and dividend and product, and then the answer. And then for the multiplication, you've got product, and so on. So we've got our green flag and our three variables declared. Then what I'm going to do is, you could initialize them to 0, but I'm just going to ask the user to initialize it. So I'm going to go to Sensing. So the light blue one is Sensing. And I'm going to grab the Ask block. I'm going to make it a little bigger so you can see. So you can see I've put the Ask block from Sensing, and I've attached it to the green flag. There's also an Answer block right beneath the Ask block. So grab that now because you're going to need it later. So I find it easier if you grab it right away. Then instead of what's your name, I'm going to change that to enter your first number. Or you could say, what is your first number? So you can type in the text area there to ask the user for their first number. We're then going to go to Data, and you'll see here that we've got the Set block. So go to Data and Set block and drag it over. And then I'm going to drag, you can see in the pull-down menu I've got Answer selected right now. I'm going to change that to num1. So set num1 to the user's answer. So see how I dragged the answer in there, the answer block, and when I let it go, it should snap in. If you approach it from the right, it should snap in nicely. If you approach it from the left, it won't work. So you'll have to make sure that you drag it from the right-hand side of that square and then snap it in. So we're going to do all of that again now. We're going to go to Sensing, grab the Ask block, grab the Answer block, and now you can say enter your second number. We can go back to Data, grab your Set block, and then snap in your Answer block, and make sure in the pull-down menu it says num2. So when you click the green flag now, it should ask for your first number. It will store it in a variable called num1. Then you're going to ask for the second number, stored in a variable called num2. Now we can calculate what the answer would be if you add those two numbers together. So while you're in Data, so again, stay in Data and grab the Set block. We're going to set our answer to something. So you're going to use the operators now to grab an addition operator. So it's the green block. So you're going to grab the addition operator from operators. It's the top one, and snap it into place. So I grabbed the addition operator from operators, then go back to Data and grab num1, your num1 variable, you can see there's a block for it, and your num2 variable, and snap it into the second circle spot of the operator. Now sometimes when you go to snap this in, you'll find that it will snap out your green operator. And so if that's the case, just click beneath and grab your num1 and snap it into the operator while it's beneath the block. And then you can grab the green part of the operator. I know it's a little glitchy on the screen there, but it should work smoothly on your program. So there you go. So we've snapped it back in. So now it asked for the first number, stored it, asked for the second number, stored it, and now it's recorded, or it's stored, the answer to the two numbers added together. We also want to display that to the user. So now you can go to looks. Now it sounds funny to go under looks when you're going to tell the user something, but it's actually the speech bubble that you're looking for. So under looks, grab the say block. Right now it says hello, but we want it to say the answer. So go to data. So I went to looks, I grabbed the say block. Now I'm going to data, and I'm grabbing the answer block and snapping it in place of where it says hello. So you're ready to run your program. So I'll just kind of repeat some of that stuff. I went to say, data, grabbed the answer block, and snapped it in. So when you click on the green flag now to run your program, it says enter your first number. So you're going to enter that into this new text window that just popped up. So I'm going to type in 3, and you can either press enter or click the blue arrow. Then your second number, so I'm going to type in 5 for my second number, press enter or click on the blue arrow, and scratch character will tell you the answer. So a little tip, if you don't want to just tell it the answer, as I have here, what you can do is use the join operator, which is under operators. So my volume is cutting out a bit. Okay. Good to know. So let me know if it continues to do so. So I'm going to go to operators and grab the join block. And I'm going to put the answer block on the second part of the join block. And in the first part of the join block, I'm going to say the answer is. And then I'm going to leave a space after the S. Here we go. So it says the answer is, and now you can see the answer. So if you run that program again, 5 and 3, there we go. So the answer is 8. Okay. Awesome, thank you, Sharon. So what I'm going to do, it could be my Wi-Fi as well, so that's why I was checking. So what I'd like you to do is see if you can change that to multiplication now. So I've made an addition program, and maybe you have as well. So what you can do now is see if you can change it to a multiplication rather than addition. And while you do that, I'm going to return to my slides. And I have the solution there. If you were just watching instead of joining me, you can go to that link if you'd like to. So that's what we just created together, and you can see I called it sum, my answer variable sum instead. And your goal then is to change it to multiply the two numbers together rather than add the two numbers. So let me know if you need any help with that. I'll give you a second to try. Alba, try clicking on the green flag at the top. After I put in so Alicia doesn't seem to say clicked. Okay, so when you click on the green flag at the top of the screen, Alba, it should ask you a question, and you have to type in an answer in the text area. So try that, and then and so, oh, good question. Okay, so Madison, yes, you can add another join block. So Madison, if you want to add a period at the end, you can add a second join block. So you're going to like nest your join blocks together. and then you can put a period at the end. So you put join blocks inside of join blocks, and you can put a whole bunch of strings together. And I saw Alicia had a question too. I missed that one. Just go back up. Your answers will come through. So just double check that you're right variables. So I'll just go back here for a second. So make sure that you have your first variable, and then your second variable in the pull-down menu, and then your third variable in the pull-down menu. So that could be the issue. I put the 3 and the 5 in the box that all says answer is, I don't get 8. Okay, so just make sure that you have the join operator, Alicia, from the operators, and then there should be a space in that join operator. So I went to operators, I grabbed the join block, I typed in the answer is, and then my variable was called answer. So I snapped that variable on the second half of the join block. So if it doesn't work out, go to this link at the top here, which Trish has typed into the window. You can just scroll up in the chat window and you'll see this link, and it will take you to the solution to the program. So just try it out and see if you can figure out where you went wrong. So awesome. So it's typical to, like, your students will have quite a few errors, and it's actually kind of fun to debug. So I actually find when I'm doing programs ahead of time, I usually practice ahead of time before I go in with my students to do them. I'm able to troubleshoot problems better if I've made a few errors, because then I can anticipate the problems and don't make the same errors as well. So hopefully you're able to multiply. Can someone just share in the window what the operator looked like for multiplication? You just have to click, thanks Lucas. Awesome. Morgan's got that as well. So I just saw a couple questions on there. Great. How do you put the answer in the blue button? So I'm not quite sure what I mean, but if you type it in on your keyboard, if you click on the text field, Cyril, you can then click on the blue check mark if I've got your question right. And Jamie, if I wanted to make an exponent calculator, could I do it with a repeat loop? So I'm not quite sure what you mean. Do you want to type in the expression you want to use, Jamie? You want to do like 5 times 5, or, and then let them choose the number the exponent would be? Because there is actually an exponent operator as well. So if you scroll through the operators, I would just use the exponent. If you go to where it says square root of 9, there's an exponent operator. So I would just do it that way, Jamie. But it might be fun to have them use a repeat loop. I'd have to try that to see how I would do it. But there is a way if you go to your repeats, you can get a variable for the repeat, Jamie, and then you can snap in that variable inside of the repeat and indicate the number of times you want it to repeat, and you can multiply inside of there. So it will work. That'd be a creative way, though, of doing exponents. All right, so I just wanted to show you an extension for you to have a look. And I'll come back to Morgan's question now. So extension, check it out. So here, I'm just going to show you on my screen. I'm not going to go to this link myself. You're welcome to go to the link, or you're welcome to just watch how I describe. So this would be an extension. Let's say you have your students do an addition program, and then you can challenge them, as someone did in a session I was at a couple of days ago. We had teachers and students in a professional learning session in Algoma District School Board. So each teacher, or we had 2 teachers from each school, as well as 2 students. And one of the students said, well, I'm going to make a calculator that does all of the operators. So not only did his program add 2 numbers together, but he also had his program do the other operators. And before I move on, I'm just going to double check that I've answered all these questions. So Morgan said, how could you make it so it gave feedback? Or okay, try again. So I'll show you when we get to a guessing numbers application with some if-then. So that will work. All right, so I'm going to go to the next slide. So this is what you'll see if you click on that link. It asks for the first number, and then it asks for the second number, which we did, but then it asks for something else. It says, what would you like to do with these numbers? A for add, S for subtract, M for multiply, or D for divide. And actually, Morgan, I'm going to show you now with the if-thens here. So those are all the different options for you to do. Now you can see I added a fourth variable. And if you look at the link called Floyd operators, this is what it's going to do. So I've got a fourth operator, another variable here called operator. So if I show you the next screen then, what I did next is I used a series of if statements, and these are called decision structures. So this is how your computer makes decisions. Your programmer will tell it to do things based on a condition. So if the person types in A, so you can see I said A for add, S for subtract, M for multiply, and D for divide. If the person types in A, then you want to add the two numbers together. So I use the add operator. If the person types in S, as we have here, then you're going to subtract the two numbers. If they typed in M, then it multiplies. If they type in D, then it divides. So then you can say the answer is answer. So it's just an extension that you might have your students do. And there's different variations of that. You can ask them for the operator first and then ask them for the numbers. I've seen it done with buttons as well. But that's just one example of an extension that you can do with this program. So once you have your students do the add, you can then have them try something else. And if you want to try it again after Morgan, you can just send me a direct message or email me, and I'll help you with that program, no problem. So you'll notice the variable names. So first of all, Dr. George Gagnon of Western University says that coding can give abstract concepts a more tangible feel, and to really feel like that's true with variables. So in math, typically we use words like X or Y or B as their variables, just because they're nice and short. But when you're using programming, we always give more descriptive names, and it makes it a little more obvious to the user, or to the people programming the program as well. So for example, if you're teaching high school and you use, some of you might remember Y equals mx plus b, so the slope of a line, what you could do instead is use the word cost for Y, rate for the m, or the slope, amount for the x value, and then the starting value, the y-intercept, you can actually use the word starting value. So it really does help to clear things out when students start to make their programs. So I'm going to show you an example of a unit conversion program, and I'll give you the link, so you're welcome to explore it. I'm not going to program it with you now, I just want to share it with you. So if you're going to have, in grade 6, you have to do unit conversions. Let's say we want to change from kilometers to meters. So to do that, we know that we have to multiply by 1,000. So what I've done here is I made a program, and you can check it out with this link here at the bottom. So it's unit conversion Floyd. Trish is on the ball. So you can see here when I click the green flag, it's going to ask the user, it says enter the measurement in kilometer. Then it says set kilometers to the user answer. So let's say they typed in 5. It will then take the kilometers that they typed in 5 and multiply by 1,000. So 5 times 1,000 will then be the meters. So it says the measurement in meters is 5,000. The operators are found under the operators drawer. Do you see that, Stacey? So when you're in Scratch, there's a whole bunch of operators in there, in the operators drawer. I think I've got your question right. So here is just a simple unit conversion, and if you play around with that program, you can see that you can change it from anything. So you can have your student, you could show the students the kilometers to meters, and then have them do centimeters to millimeters or something like that. So it's just after you teach them the adding two numbers, you can then have them do unit conversions. Okay, so there's some other unit conversions that you can do. You can go from, maybe you can start having conversion factors, so have them convert from pounds to kilograms, excuse me. Or you can do inches to centimeters, or you can do teaspoons to milliliters. And so that makes it a little bit more tricky, but the students will have to use their knowledge of conversion factors for that. So here I've given you an example. Let's say we want to convert 5 pounds to kilograms, so they would you'd have to go through this first with the students so they know how to do it in the program, but they take 5, they multiply it by 1 over 2.2. We cross off the pounds, you end up with just kilograms, so 5 divided by 2.2. So that would be how you can do your conversion factors, more confusing unit conversions. Oh, I understand now, Stacy. And Scott, thank you for answering. So I created that variable. So on the next slide here, we can go ahead and code a guessing game together. I'm just checking the time. What I'm going to do, rather than code it with you, is I'm going to give you the actual link. So if you click on this link, let's explore it together. So I'm going to share my screen with you, and we will explore this rather than code it together, just so I have a chance to show you a few others today. I want to make sure I get through a couple other programs. So I'm going to share my screen with you now. All right, so you should see the guessing game application, or you can click on Tricia's link there, Guess Game Basic. So this is a guessing game, a number game that you can do with your students, and I'll show you an extension to this in a moment. But I declared a variable by clicking on Data, and I have 2 different variables here. You can see that I have a variable called Guess and a variable called Number. At the beginning of my program, you can see, I'm just going to break it apart now, I grabbed the set block, and I changed the number to a random number. So under operators, you will see this random number operator, and that's what I used. So I kept my numbers between 1 and 10, but you can have your students choose any number or any range. Some of them like to make it a really big range. Then I used what's called a repeat until block. So that can be found under control. And I used the repeat until, and that's because I wanted to continue giving the user a chance to answer to guess the number. So as soon as the guess is equal to the random number, it will stop repeating, it will stop asking the user for their guess. So if you run the program, so right now I have it so you can see what the number is, what the random number is, so it's 3. But what you can do is go to Data, and you can see that I can uncheck those boxes, and then the user won't be able to see what the random number is. But I'm going to leave it up because it helps to troubleshoot our programs. So let's say I typed in, so I can see that the random number is 5. So if I type in 5, it should say, no, it's guess again. And it'll wait a second because it says 3 seconds. And I'm going to type in the number 3, and it should say yes. And then it's going to stop asking the user. So on your slides there, I'll show you this next program, but there is a link. I just don't want to go toggle between the two, but I'll give you that link in a second. So here we have a more advanced program. So let's say you want to start getting into greater than and less than signs. You can take that program that we just used and add some decision structures. So what we did is I still had, and you can do this with your students, I always like to give them a base to their program, and then you can have them add to the program, or you can remix the program together. So here I still have my repeat until block, but rather than just say, no, that's not right, and yes, that's correct, I've added some other ifs. So you can see my ifs here, and I say, if the guess is correct, then we want to say yes. But then if you look on the next part, it says, if the guess is less than the number, so I used a greater than less than sign, and that can be found under the operators. Then you want to say too low. Then if the number is bigger, if their guess is bigger than the actual random number, then it'll say too high. So if we run that program, we'll try that together now. So I can see now that my random number is 1. So if I press 4, it will say too high. If I type in 0, it will say too low. And if I type in 1, there we go. Oh, sorry, Marian, I just have to go back to my slides to show you the link for that. So I just wanted to show you while I was sharing my screen, and now I'm going to go back and then we can see the link. So it's called Guess there we go, guess game detail. So what we did there is we just added some extra comparison operators and extra decision structures to indicate to the user whether the number is too big or too small. So for this program, I'm just going to show you while we're selected on here, but you are welcome to go to this link. So Coin Flips Floyd, lots of links for you today, and again, I'll give them all to you at the end, so you can explore all these programs with your students if you wish. So this is a coin flipper program. Now, I have a number of programs, or a number of variables here, but the main variable that we're using at the beginning is a variable that is a random number between 1 and 2. And what I do is, if the random number shows up to be 1, then we're going to say that that's heads, so this heads will appear. And I also am keeping track of the number of heads, so when you run this program, you will see every time you hit the space bar, so it's the space bar, not the green flag, every time you hit the space bar, it will flip the coin again. So if it's not heads, it will appear to be tails. And it's also keeping track of the number of tails, so it's changing the variable value for tails. Then what you can do is we've got the total number of flips, so I'm keeping track of the number of heads and the number of tails, and then I've also calculated the percent probability for number of heads. And you could do the percent probability for the number of tails as well. So there's for the coin flipper. And Shannon asked a great question. How can you keep track of the number of guesses for the guessing game made before they guess the number? Well, you can actually do something like we've done here. So every time they select the wrong answer, like if it's too big, you can increase a variable that's correct, or a number of guesses inside of the if-then. So here, when it's a head, I have the change number of heads by 1. If it's a tails, I have the change number of tails by 1, and you could do that for your guesses as well. So you could have a new variable called number of guesses. So that's, again, is an extension to everything we've done. You could just do a coin flipper, but I've added to it by taking the total number of flips. So in some cases, I would have my students do a coin flipper, and then I say to some, okay, can you keep track of the total number of flips? And then I say to others, okay, can you give me the percent probability for the number of flips? So there's lots of options to extend your tasks there. So this is a fun program. We're going to do this one together. I've pre-made it for you. So Trish has the link in there, and I'm going to share you my screen. Okay. So I've got a bit of a skeleton program here for you, and I'm going to add to it. I'll make it a little bit bigger so you can see. So what this program has is in the background, you can see it has a Cartesian plane. At the center of the Cartesian plane, you'll see a purple dot. And that purple dot is currently at 0, 0. So when I click on the green flag, the purple dot should move. I guess it looks kind of pink on your screen, but that dot will be at 0, 0 because that's what the code says. It's going to clear if there's anything on the screen and go to 0, 0. Down here, you'll see a repeat block. So I'm just going to add to that code now. So what I'm going to do is I'm going to have the user enter in an x coordinate. They're going to enter in a y coordinate, and then it's going to plot it for them. So we're going to go to data, and we're going to make a variable. So under data, make a variable, and call it x coordinate, or x coordinate. Or you could just call it x, whatever you prefer. So that's our first variable. Then I'm going to go to data and make another variable, and I'm going to call it y coordinate. And then click on OK. So now we've got an x coordinate and a y coordinate. And then I'm going to ask the user for the x coordinate and for the y coordinate. And we're going to do that 10 times, which is why there's a repeat block. So we don't actually have to ask them 10 times. It will repeat it for us in the code. So go to sensing and grab the ask block and also the answer block, because we're going to need that. So inside the first ask block, I'm going to say, what is the x coordinate? Now with the younger students, you'll find they won't type as fast as that because they're used to using tablets. So what you could say is just x or x coordinate, and then it will speed it up a little bit. So I'm going to snap that inside of my repeat block. So I went to sensing, ask, and then I grabbed the answer block as well. So now you're going to go to data. Okay, so I went to data, and I'm going to set my x-coordinate. So make sure you select the x-coordinate. This morning I was doing a program and I had 2 y-coordinates. So it looked like it was working, but it actually wasn't. So I'm going to drag my answer block, which is from under sensing, inside of the set x-coordinate block. So I've got the x-coordinate now, but now I need the y-coordinate. So I'm going to go to sensing again and do the same thing. I'm going to grab the ask block and the answer block, and I'm going to type in what is the y-coordinate. And I'm going to snap that beneath that set block. Now you'll find it takes a little getting used to, like you might have things in the wrong order. So it just helps if you pull down from the bottom and then move something out of the way and then snap everything back together again. So we need a set block again. So under data, after you ask for the y-coordinate, you want to set your y-coordinate equal to the user answer. So as you can see, I've done that. And everything else is ready for us. So if we run our program, what is the x-coordinate? You're going to type that into this blue text window here. So I'm going to type in, it helps if you use multiples of 10 here because the way the Cartesian plane is in Scratch is a little bit small. So I'm going to type in 100 for my x-coordinate, 100 for my y-coordinate. I'm going to type in, oh, you know what I'm missing? So you can see I've done all this. I've gotten the x and the y coordinate, but then I actually didn't do one particular block that's really important here. I need the glide block. So I'm going to go to motion. And those of you who have more experience with coding probably noticed my error. But I want to go to motion and grab my glide block and snap it above the stamp block. So glide block and snap it above the stamp block. And I'm going to go to data, and that's where your x and y coordinates are stored right now. So you're going to drag the x coordinate into where it says x, drag the y coordinate into where it says y. So there we go. Now when I run my program, I'm going to hit the green flag to run the program. It says, what is the x coordinate? I'm going to type in 100. Then I'm going to type in 50. It's going to plot that. Now it asks for the next one. So I'm going to do this 10 times. So you can change it. I'm going to change it just to 4. So it doesn't ask me for so many. And what is the x coordinate? So I'm going to use a negative number here. There we go. And okay. So once you've got all your points, so you can change it to the number of repeats you want. What you could have your students do here then is try and plot them into the squares that I have. So I added squares to the background. So if you want to, you can have them try and plot the x, y coordinates into those squares. So there's an extension for you. And I have a couple other extensions to share with you, but that's the basis of that program. So I'm going to stop sharing my screen here. So that was a little tricky. We did quite a bit of blocks there, so if you have questions, you can let me know. And again, you're also welcome to email me later, and I can help you with that. Okay. So what you could do next is you could plot them in each of the squares, as I mentioned already. You can also have them try and plot a positive correlation. There you go. Or you could have them try and plot a negative correlation. Or you could have them plot all the points in the third quadrant or all the points in the first quadrant and so on. You could have them plot it in the shape of whatever you want. Maybe they can try and plot it in the shape of a heart. So every time you plot it, the dot will go to that point. And I'll get to your question, Alba. And then I have check out this extension program using lists. So this next program is quite challenging. So before I go to that, you can click on it if you're ready. I'm going to answer Alba's question. So what does the stamp and next costume mean in the repeat block? So I didn't actually explain that, Alba, so you didn't miss it. So the stamp block will stamp that sprite. So if you had, like the first time I had like a purple dot, So that purple dot will stamp once it goes to the XY coordinates. And then next costume just goes to the next color of the sprite, of the character. So it'll be like blue, then red. Oh, and Alicia, I didn't even notice you answered my question. Perfect. Awesome. So this next program then, so it's called Graphing with Floyd. If you go to that link, I'll show it to you on my screen actually, and you'll get the links afterwards. I'm just going to click on my sharing here. So I'm going to show it to you on my screen, and should have it in the window as well. So it's up to you if you'd like to follow, just watch. We're not going to do anything here. We're just going to, well, we're not going to code anything. We're just going to look at this super extension. I was kind of proud of it because I did this morning. It was something extra that I thought of. So this is using a different kind of variable. It's actually called a list. So I'm going to run the program for you and just to explain it. So I'm going to click the green flag. It says, how many points would you like to plot? I'm going to type in 3. What's the first x, or the x coordinate of the first point? So let's say it's negative 100. The y coordinate of the first point, I'm going to make it negative 100. Now notice it keeps track in a list format. That's a different kind of variable. So if you're wondering under data when it says make a variable or make a list, there's actually a way to make lists, and that's quite advanced. We don't usually do that until you know, maybe end of grade 10 computer science in high school or grade 11. But with Scratch, we are seeing some students doing lists like this in elementary school now. And there is ways that you can incorporate them, but it is a little tricky. So I just wanted to mention that you can do that, or you can encourage students to check out the list. So after they complete their plotting points program, maybe you can say, I would like you to check out the list. So you can see after I enter in my XY coordinates, it will then plot them all for me there. So it's just like a little bonus for you to try with your students if you want. So I'm running out of time here, so what I'd like to do is go back to my slides, and I'll show you a couple other things that you might want to try out. So I'm just going to describe this one for you. So this is something you have to do in grade 5. You have to have your students be able to convert from a 12-hour to a 24-hour clock, or from a 24-hour to a 12-hour clock. So in this case, let's say you ask them for their time in 24 hours. Let's say it's 13. So it says, is the number that you just got greater than 12? If it is, then you go this direction. And if it is greater than 12, then you take the 13 and you subtract 12 from it, and you should get 1. And then you also know that it's PM. So your final answer would be 1 PM if the input originally was 13. Now let's say they said 10. Okay, so that means it's not greater than 12, it's less than 12, so the answer would be no. So we want to keep it at 10. And then because it's not greater than 12, we know that it's AM. So the final answer would be 10 AM. So you can go through examples of how you would normally teach that with students, and then if you want, you can have them code it in Scratch. So here's a program for the 24-hour to the 12-hour clock. And if you click on the link that Trish has provided for you, you'll see this program. And this is the code here. So it asks the user for the time in 24-hour clock. It checks if it's greater than 12. If it is, then it subtracts 12 and it puts a PM. Otherwise, it will just keep the time the same, and then we know that it's AM. So there's a 24-hour to 12-hour clock program that you might want to try with your students. And I have a task description if you want to check it out, and Trish has already got it there. So there's a PDF, and that's an assignment where I just describe how you might teach it with your students. There's the program, and there's actually a video as well explaining how to make that program. So you can have your students watch the YouTube video of me explaining how to make the 24-hour to 12-hour clock program. Now let's say you wanted your students to make a square. So here's the code to make a square, and I know there's a lot of beginners on here, but this is a wonderful place to start. You don't even need to use variables when you're making shapes, but if you go to my blog, lisaannfloyd.com, or if you just search how to make shapes in Scratch, you can learn how to make a square. So in this case, when I click on the green flag to run it, it points in the right direction, goes to 0, 0. But the main part of the program is this part here. So to make a square, you walk you move 100 steps, you rotate 90 degrees. So you move 100 steps, scratch world, that's not very much, then you rotate 90 degrees, and then you, because it's a repeat of 4, you move 100 steps, rotate 90 degrees, move 100 steps, rotate 90 degrees. So there's my square. But then what you could do is interact with your user a little bit. You can say, what would you like the length of your sides of your square to be? So you have a variable now called length. And what's cool is that the students can make their program and we'll run it, and then the length for the square will be whatever the user typed in. So if they typed in 200, then they'll have a square with 200 steps on all the sides. So it's just a way to interact with the user and have it vary. Now you can do this by asking the number of degrees as well, or number of sides. So let's say, how many sides of the polygon would you like? So if you ask them, if they say 3, then what you would do is take 360 and divide it by 3, because it's actually the extra angle here that we care about. So it would be 120. Then you would enter the degrees into here. So you could actually ask the user for the number of sides and then calculate the degrees for them. So that's just an extension, once again, that you can try if you want to incorporate variables. You'll notice that you're getting immediate feedback here. So if you have any mistakes, they know right away. So they're not sitting there waiting to find out if it's right or not. It's not like you're walking around your classroom and then you discover after the student's been working on it for a while that there's a mistake. It's neat because they're getting feedback right away and they know that they have a mistake. So they're able to try and fix it, and if they can't fix it, then they usually seek help from their peers and then the teacher as well as a last resort, which is kind of an interesting shift in the way the classroom is run. So here's another example, and for this one I'm just going to show you once again. Here we have another interesting shape. And I explained this in I think the very first blog post that I did, how to make a square spiral. So here, let's just go through the code. So we're going to look, this is sequential code, it's just one line after another. So we move 5 steps, which is a very small amount. Then I rotate 90 degrees. So imagine yourself rotating 90 degrees. Then I move 10 steps, which is twice as long as the 5. Then I rotate 90 degrees. Then I move 15 steps. Then I rotate 90 degrees, then I move 20 steps, and I keep going until I get this shape that looks just like a square spiral. Well, that's not really efficient, and it would take you much more than what I have here to make this square spiral, because it just keeps going and going for quite a while. If you go on to the next slide here, you will see that I actually have code that's much more efficient. So I've used a repeat of 50, but I've also used a variable. So my move amount variable is set to 5. And what that will do, so at the beginning it's 5. So there's my first 5 right at the beginning. Okay, there's my first 5. Then it puts my pen down and it says move amount steps. So there's where it does the 5. And then it says rotate 90 degrees. Then it says change move amount by 5. Repeat. So the next time my move amount equal to 10, rotates 90 degrees, change move amount by 5. The next time move amount is 15. So you can see I'm doing the same as what I did here, except for now I have a loop, and I can do that as many times as I want. I can just adjust my 50. So it's a really cool way. You can challenge your students. You can just show them the shape and say, can you make it? Some of your students will make it in this way, which is less efficient, but at least they still thought their way through it, because it's pretty tricky to make. And then some of the students will be even more efficient, so there's a little extension for you to try. So let's just have a little review here. We've got declare the variable, so then give it a name, and in Scratch we do that under data, make a variable. Then we tend to initialize the variable, and I didn't do a lot of initializing in Scratch where I set it equal to 0, but you can do that when you can set it equal when you do the sensing block. So you say, what is the value that you'd like, and then you store it. So that's another way to initialize it. Then the third way is to use the variable, and that is to update the variable. So the move amount updated by 5, we added 5 every time. So now that we've reviewed that, I thought I have enough time to show you this. I think this is a cool music example. So I don't know, do we have any, maybe just put your hand up if I won't bug you, but I'm just curious if there's any music majors or anybody interested in music in here. Anybody? Anybody? Oh, yay, someone is. Maybe I will pick on you. Okay, so a couple of people are. Awesome. I can only ask that question. Nobody has any music background, so now I'm nervous. All right, so I'm going to show you this program, but before I do, I just want to mention that in Scratch, you can actually there's a keyboard in Scratch, and I think the best way, thank you, that's Madison's helping us out here, so the best way is to go to this link. So let's go ahead, and Trish has already got it for us, and I'm going to share, well, you can actually go to the link, and then I'll explain it. So if you don't mind just looking at the actual Collaborate screen for a second. So I want to show you my slide. I knew there's a reason I wanted to show this, I just couldn't remember. So on my screen now, you'll see that I have a keyboard. So it's just the black and white keys. Well, if we only pay attention to, we don't care whether the key is black or white, we only pay attention to the numbers. So I've numbered the keyboard here. So I've got 1, 2, 3, 4, 5, all the way up to 13. Now that would be called a chromatic scale. So if you took your finger and you hit the first note and then went up to the black note and you did every single note until you get to the other C, so there's middle C up to the next C, you would be hitting 13 notes. So that's a chromatic scale. And you can see my code is there. I start my note at 60, which in a second I'll show you on my screen is middle C, and then I go up by 1 13 times. So when you play that, so I'm going to share my screen now with you. Okay. So in order to play that one, I have to hit this. Whoops! I have to hit the space bar. So if you click on the note here, I'm just going to move that out of the way. It doesn't like that because it's got to repeat, but you can see that the keyboard will indicate what is the note. So for 60, 60 is always middle C in every programming language. So that's how you do chromatic scale. Well then, let's say we wanted to do just a scale like do, re, mi, fa, sol, la, ti, do. What you'll notice is, well, I'll just play that for you. So if I hit the green flag, so I'll have to show you my slides again to explain that. But just look carefully. You'll see that there's a repeat of 2, and I'm changing my note by 2. Then I just go up by 1. Then I change my note by 2 3 times. Then I go up by 1. So I'm going to go back to my screen now. So here again, if we, instead of doing the chromatic scale where we hit every note, we just want to hit all of the notes from do to do. So when you go from C to D, you have to go up by 2 because we're skipping a note here. Then for the next one, we're skipping another note, so we're going up by 2. Oh, then there's no black note in between, so we're just going up by 1. Then we go up by 2, 2, 2, 1. So then you can see the pattern. We've got play a note, then go up by 2 times, so there's 2 times. Then we go up by 1, there we go. Then we go up by 2 3 times, so there's 1, 2, 3, and then the last one is just play the last note. So what you could do is change keys really easily. So without knowing, whether they're sharps or flat, so let's say we can change to the key of D. So your starting note then would be 62, so 60, 61, 62. So this would be note 62. If we change this to start on 62, then it would be an F sharp and D sharp because we're in the key of D, but it would still work. So then you have everything, so you'd be going 2, 2, 1, 2, 2, 2, 1. So it would work no matter what key. So I just thought that was kind of neat for those of you who are music majors to see that you can code some music. And I've had students make incredible song compositions by programming it in Scratch. And you can even just have them program it with like Twinkle Twinkle Little Star or basic programs, and then they can try and use repeats to make their code more efficient. So then they're using pattern recognition in their songs. So you noticed that we made lots of mistakes throughout that, even when I was programming with you, showing you some stuff. I've made some mistakes. What I do find, by the way, is if you're teaching it to students, sometimes you might take a picture of your code if you practice it ahead of time, and then when you're doing it in front of the class, because sometimes when you are put on the spot, it's a little bit scarier. You can just take a peek at your phone to see the code, but you also want to model for your students debugging. So when you're programming, you're going to make tons and tons of mistakes. And Seymour Papert wrote this book, so in the 1980s. It's called Mindstorm. So Lego Mindstorm is named after this book. And he says that typically in math class, a child's reaction to a wrong answer is to try to forget it as fast as possible. In coding, however, the programmer is encouraged to study the bug rather than forget the error. And he goes on to say that it will pay off. And I think most of us, or all of us, probably have taught math at some point, and we kind of picture our students, frantically erasing their mistakes. But in programming, we almost see them as kind of fun challenges, and students will crowd around their computer and help each other out to solve the problems. And we learn from our mistakes. And if students are getting things right the first time, then they probably haven't learned anything, and we're not challenging them enough. So with coding, they make all kinds of mistakes, and they're not afraid of it. They just go and fix them, and they just keep trying and trying until they get it right. I like to call these opportunities, or all of these mistakes, points of opportunity. So in our classes, they make a mistake, and it's just another opportunity. And you can see the acronym that I use for that. Also, we should consider our students, just as software is considered to be in like software applications when they first come out, they're considered to be in a state of beta. So they are constantly getting feedback from their users. They're asking their users, can you find some mistakes and send it back to us, and we will make our programs better. Well, our students should also be considered to be in beta. They're always evolving, always pushing, always improving. And I saw this in a New Balance ad recently, and I think it's great if we can consider our students in beta, just like in the software industry does. We can also consider ourselves teachers as well as being in beta. So some days you might feel like our class went horribly, but that's okay because we are in beta mode. So just like learning how to code, there's always more to learn. And we should consider ourselves constantly updated. Really, as educators, we're students in the teaching field. And we're constantly downloading and installing, and maybe we do that, during a lunch and learn or a conference or on a webinar on a Monday night. So it's sort of like updating your operating system, and as you do that, you're going to find glitches, you're going to find compatibility issues, but at the end, it results in progress. So we need to consider ourselves, you're not going to be experts in programming and coding yet. I certainly am not, no matter how many years I've been doing it and how many programs I make. But I do consider myself an adaptive expert. I'm recognizing that I need to improve. I'm recognizing that I need to continue to be a lifelong learner. And I do kind of consider myself an adaptive expert in pedagogy. And all of you, with all of your experience, should have confidence in that ability to make appropriate decisions when it comes to your student learning. We also have to be willing to be responsive to our students' needs. In some cases, it might be to do, some coding, or you might make decisions to do other things in your classes. And even how you approach coding will vary depending on the group of students that you have. So we can all consider ourselves to be adaptive experts. Finally, I also just want to mention that I think we hear often, just go and code with your students. But I do think it's important after, maybe do that every so often. But I do think it's important that we take the time to try and do it ourselves as well, just as you all have done tonight. So, and then we can give our students some of the tools and the methods that they need to create programs. So like I've given you some programs to try with your students, and I've taught you how to do some of the methods. And then once you do that, then you can have them create. So sometimes just telling students to create without giving them any tools will result in them not creating something as amazing as what they could. So the stars we're given, the constellations we make, give your students the stars and then see what they create from those tools and those methods that you've provided for them. I'll have this on the link for you at the end, but here's a few resources for you to check out. Jim Cash has some awesome programs in Scratch for junior intermediate grades, and he also has a really neat blog. More recently, he wrote a post about how to kind of go beyond the hour of code, since the hour of code is coming up. Dr. George Gadanides has his website, imaginethis.ca, with a whole bunch of free math and coding resources. Also the Math Knowledge Network, which is a Ministry of Education site. They have a computational thinking pillar now. So if you go there, you should see some resources shared. And over the next couple of weeks, you'll see TVO, Teach Ontario. My husband and I are working on that, and it will be released. Stacy, who's on here, Jamie, who's on here tonight, I saw, and Scott will have some stuff shared on there. So that's for educators to learn from and to share your own resources as well on there. So you'll see that over the next couple of weeks or so. We should be releasing that. So thank you so much for joining me. I really appreciate that you all stuck with it. I know that I showed a lot of resources there, and I'm sure it was overwhelming at times, especially because we had a lot of beginners. But I hope I've inspired you or encouraged you. I do encourage you to check out this link that Trish put in the window as well. And on that link, you'll have all of the links and the programs that I showed you today. And hopefully you'll be able to use that in your own classes. And as we get to our code this week, so next week rather, everyone's going to be doing a whole bunch of tutorials, and some of those tutorials are pretty good, but I do encourage your students to try out programs like Scratch, where they're able to create something kind of neat afterwards. So once they go and use the tutorial, they can then create something of their own and be creative. And maybe get them away from the screen and try some programmable devices like Sphero. Scott McKenzie, who's on here, has some awesome. Maybe you can enter your Twitter handle there, Scott, so people can follow you. He has a lot of great Sphero and other activities as well for especially primary grades with Scratch. And there's microbits, and there's a lot of opportunities to encourage collaboration and students to work together. Thank you, Scott. So thank you. Hopefully you enjoyed that webinar, and I'll pass it back over to Trish.
Wow, that was quite something. My goodness. Wow, that. So I want to thank Lisa. That was a wonderful presentation. And I know that we had so many resources in there. I love how you found some examples for all the grades. And it's always fascinating to see what the next grades might be doing as well, too. So terrific. My job at the end is to make sure that we get your feedback as well too. So I'm going to put a couple of links into the chat. You do the survey first, and once you've done that, it will prompt up a certificate that you can have as well too. Your feedback helps drive what our next webinars could be in the new year. And if you'd like to see some more coding, that's a great place to put that on there. And also, the resources will be listed. You are all going to get an email tomorrow, and it will take you to the OTF website as well so that you can see Lisa's resources all there. And I'll certainly put in the Google Doc because she's done a great job of describing those resources. As I mentioned, we've got lots of great webinars coming up. Some more people that are tackling many, many ideas coming up. Mindomo is this Wednesday. It looks to be a good one as well, too. So please make sure you check out our OTF resources. And finally, don't forget, this is still active. You can get subsidies at for AQ courses from OTF, and please take advantage of that one for sure. And so that gets me to the end of my thank yous. I am going to stop the recording shortly, and I'll give you a few minutes to check out the surveys, and I'm sure Lisa will hang around for a minute or two and answer any more questions. But that's it for us tonight. Thank you once again, everybody, for joining us from wherever you are tonight, and hope to see you again.
And